that stuff. All right, everything looks like it's working there. That's exciting. Everything looks properly in place. And minimize that. And let's close the let's minimize the browser so that we don't have that distracting us from the important work that we need to get into. Make sure that we're in the right database for all this stuff. Because how else can we live if we are not in the right database? We'll have to be, we'll just be stuck. Hello everyone. Let me, oh, what the heck? Let's see. This should no longer slideshow. This should be pretty static and in place. There we go. Now we're looking good. Cool. So how is everyone today? What are we all up to? What is today? Wednesday? It is. It is Wednesday. It's fantastic. That means the week is nearly over. The week is nearly over. We are almost to Friday, which means there are only, let's see, Thursday, Friday, Saturday, Sunday, only 4 more days of work until Monday. It's going to be fun. All right, so I don't know. Do some small talk. We'll wait for some people to show up in here. Wait for some more eyeballs to jump on in. He says I have the next days off. Not sure why I'm broadcasting. I don't know. Like you have the next 2 days off, and then the weekend, right? Or do you have the next 2 days off because you have to work the weekend? Because I've definitely run into some people who have had that problem in their life. It's like, yeah, my boss gave me this like Tuesday and Wednesday off. Like, oh, cool. Why? It's like, I have to work the weekend. I'm like, oh, well, that sucks. You didn't really get days off. You just switched days around. 4 days. You're just making it. Hey, thanks for calling the chat boring. That's nice of you. And then also thank you for dragging down the boring chat with your boringness. Just everyone just pile on. Do we have any other insults for the chat while Lee is busy? So I'm gonna need a couple other people to step up and volunteer to hurl insults at me while Lee is off of work and probably not watching me do anything. So hopefully someone in the greater SQL Server community will be able to step up, fill those big shoes, and call my chat names. Today I've got proper seltzer back. I mean, by proper seltzer I mean it's not flavored. So I feel much better about myself. Much better about myself. All right. Since I think everyone understands what we're going to be doing today, I'll stick this one up behind me for now. Let's see. Oh, that looks pretty. That looks pretty. So I've got over 70 people slated to show up on Friday. And I'm mildly terrified now. At first I was just like, you know what, I should pack in as many people as I can, and now I'm like, man, I better not screw anything up. No pressure though, right? No pressure. No pressure. Just recalling about it's gold. Yes, I wish more things that I owned were gold so that I could sell them. I could sell them. I could buy gym equipment, and then I would not have to wait until maybe phase 4 of New York's reopening to go see a gym. That would be all that I did. Now I'm curious, like, now I'm thinking, like, you know, there's going to be a lot of people, or there's going to be a lot of gyms that are closing. I wonder if I could, like, buy some like, going out of business gym equipment. But then I'd just be very tempted to just, just open my own gym. Get the hell out of this computer thing. Computers are terrible. Have you ever used one? Computers are absolutely miserable. I hate computers. I want nothing to do with them anymore. They crash on me constantly. They don't listen to reason. Let's see. Lee says, yesterday I learned that CX packet is not to be ignored. I love SQL Server. Every day I learn something new. So Lee, why would you not, like, under what circumstances should you not ignore CX packet? I look forward to hearing about this. Let's see. If you bought a gym with gold, would you make it a gold gym? No, and I tell you why. There was a brief period of time when we lived in Austin, Texas, and I got a membership at the Gold's Gym in Austin. And I paid for a year up front because they had some special on it, but we ended up moving out of Austin after 6 months. So like 3 months in, we were like, I'm out, we're leaving. just can't do it. It was too much of like a weird culture shock. Not like politically or like anything like that, but like just having lived in New York forever, not being able to get like real Chinese food and like pizza being served on Wonder Bread and it being hot and there being bugs this big. There was just a lot of reasons why it didn't work, but I was like, yeah, Gold's. I'm leaving we're out of here. We're leaving Texas. We're not going to be there, and we're not going to be here. You know, I've paid for a year. Is there any way I can get any of that back? And they said, where are you moving? I said, well, moving back to Brooklyn. And they said, well, we can't give you a refund because there's a Gold's Gym within 25 miles of where you're moving to. I said, 25 miles? Where is this Gold's Gym? And they pointed, and like there was like some Gold's Gym map where there is a Gold's Gym like way out on Long Island. There's one closer in Brooklyn now, but it wasn't open then. And they were like, there's one out on Long Island. I'm like, no, do you know anything about New York? Is there like this? Do you have like the slightest clue how things work here? Because no one is traveling from Brooklyn out to like wherever on Long Island to go to a gym and then come back. Like it was just like insane. If there was one in the city, or if there was like another like gym somewhere in Brooklyn, that'd be a different story. They're like it was like 15 miles away on Long Island. I'm like, well, that's not good. Gold's Gym, are they like, no, the Gold's Gym that I was going to was more expensive. I want to say it was like $600 for the year or something. Like it wasn't a big deal that I didn't get the $300 back. I was just like, I was mostly annoyed that they were like, there's a gym within 25 miles. I was like, yeah, that's gonna happen. Let's see. I could buy a 24/7 gym. The problem with a lot of 24/7 gyms is that they don't have good barbell equipment. So I would have to buy the 24/7 gym and then probably import my own barbell equipment. Lee says, I used to think it was a safe weight type, but I found out that query with uneven thread workload all get even memory grants. Since your memory just sat there doing nothing, lazy thread. Yeah, so I wrote a post a while back about that. Oh, it was over on Brent's site though. Hang on a second. But it was I mean, not exactly about CX Packet. So a while back, Microsoft decided to split CX weights into two different categories: CX Packet and CX Consumer. And of course, CX Consumer is like the coordinator threads waiting on things coming on in, and CX Packet is still queries going out there and running and doing stuff. So there are times when you will have a query with skewed parallelism, and on older versions of SQL Server, you will see that register as high CX. You can see that register as high CX packet. On newer versions of SQL Server, you will see that register as high CX consumer. So, well, that can be a sign that parallel queries are skewed in some way in their row distribution. Yeah, I mean, like, it's certainly something that you could. It's certainly something that you could look at when you're dealing with a parallel query. But I think in general, if you see high CX packet weights on a server, it's not necessarily a sign that every single query is terribly skewed all over the place. There's a chance. There's a chance. You could also just have high CX packet from queries going very, very parallel. there's also that. Let's see. Let's catch up a little bit here in chat before we get started. We'll get started in a couple minutes here. Let's see. Ah, yes. Congrats on getting a call up from Itzik Bengan. Yeah, that was a crazy. That was a crazy thing to happen. I was just as shocked to have that come out of nowhere. I was like, what the hell? That was crazy. All right, so let's get started and talk a little bit about some query tuning. Oh, just really quick, in case anyone who's joining today who hasn't joined the last couple days, doing a thing on Friday all day, advanced performance tuning. If you feel like joining, you can get a ticket. You can get a ticket for very cheap. $125, includes access to all of my SQL Server video training, which is like 24 something hours of it, and well worth it. Well worth it. He says it's something on my list to look into more, though. Or also, see, no, you're getting ahead of yourself a bit, Lee. I think you're just saying words that you've heard now. All right, let's get the heck out of this thing. Let's go look at demos, because that's where all the good stuff happens, right? When we start doing demos, right? Everyone loves demos. That's where you learn everything. So let's clear out everything. Oops, I didn't highlight everything. All right, we're going to create some indexes, and while we create some indexes, we're going to look at. So this store procedure started off as a thing that I wanted to show as one way of dealing with a parameter sniffing issue. So like, you have a store procedure or something else that accepts a parameter, and what happens next is parameter sniffing, because at some point, despite all of your best efforts to reasonably index for things so that you have selective columns and you cover all your bases, even if you like, not every value in every column is going to be selective, and part of the whole selectivity thing is that values in columns being selected, or being selective rather, does kind of depend on how people are searching them. So, if you have a string column and every string is semi-unique, that's fine if people are searching on equalities. But as soon as people start putting wildcards in, selectivity kind of can get hurt. And the same thing with dates too, right? So if you have date ranges, and someone searches for like the last week, that can be pretty selective. If someone searches for the past 5 years, that's not as selective. If you have, prices and you want to search a range of prices, things that cost between, $90 and $100 might be fairly selective, but things that cost between $0 and $1,000 might be not as selective. So, selectivity not only depends on, like how unique the data is at face value, but also kind of how people search that data, right? So there's stuff to think about there. And parameter sniffing can really happen from either situation, or sometimes it takes a combination of parameters for it to show its face. Like you need to have like two non-selective parameters or something. But this is a stored procedure that I wrote, and I wanted to show one way of handling issues with parameter sniffing. And when I teach about parameter sniffing, I try to keep it as simple as possible parameter wise. So this just takes this stored procedure just takes one parameter for vote types over in the votes table in the Stack Overflow database. And just to kind of give you an idea of what that looks like. From. That's a good job, right? Never trust a professional presenter. That's the vote type ID count. We'll do a big count because we are big counters. And we're also going to nicely format our count, right? Because the only thing more annoying than big numbers is big numbers without commas, because they're hard to read, especially if you're as dumb as I am. And we'll call this records to hopefully annoy some people. Let's see. T-Vac says, is parameter sniffing something new, or it's been there for years, like dating back? It has been a problem for as long as there have been parameters in databases. It's going back to forever, basically, since like the dawn of databases. It's called some different things in different databases. In Oracle, I know they call it parameter peaking, or like binding parameter peaking, because Oracle just calls it something a little bit different. But in SQL Server, it's been parameter sniffing, or parameter sensitivity is probably the nicer way of saying it. But it's been around just about forever. The term itself, I don't know. I don't know the history of it that well. It's a good question. I don't think I know the etymology of that one. It's not like query bucks, where we very much know that it was Kendra Little who came up with the term query bucks, because Kendra is one fantastically smart cookie, and she says funny things constantly. Oh, I made my first big mistake. Does anyone see what I did wrong? Does anyone see what I did wrong? Someone in SQL Pass says he invented it. Ha ha ha! You'll have to tell me who that was. I would like to know who that was. But this result set sorted very, very strangely, and it sorted very strangely because I am converting this count to a comma delimited string, and so now SQL Server thinks that this is a string and not a number. So we have to order by the plain count if we want to get things back descending. Yes, varchar ordering, bummerino. Not my favorite thing in the world. Let's see, do I have zoom it turned off over here? I do. Wonderful. All right, cool. We are limited to zooming over here. That is just what I wanted. So when we look at the vote type ID column over in the votes table, we have many, many different vote types. Well, not many. We have about 16 vote types. But this is one of those selectivity things where, up at the top, we will have vote type 2 with 37 million rows, and down at the bottom, we have vote type 4 with 733 million rows. In the middle, we'll have some values that are a little bit closer together. Like, we'll have some that are up over 1 million, and then we'll have some that are under 1 million, but still a fairly good amount, and then some that are just kind of like less than that, right? So there are like 3 or 4 different, like, how are the categories, like 3 or 4 different categories of selectiveness within this column. And when you think about trying to index for selectivity, this is the kind of stuff that you sort of have to take into account, because you really do need to, look at how people might be searching these things, especially if someone was going to search a range of vote type IDs. Like if someone, did not just do an equality on one, or like if someone did like 40 million rows, 37 million of them are going to be vote type 2. So selectivity isn't just a guarantee, right? But we got this stored procedure, and what this stored procedure does, it will search on vote type IDs, and that's what sort of this first part does, right? We get some data from the votes table, where vote type ID is equal to vote type ID, and we want to find votes where, I don't know, we have posts that, so I'm going to tell you a funny thing about this demo query. It does not make the most sense in the world given the Stack Overflow schema, but it works really, really effectively as a demo. So I'm not even going to try to explain what this thing is actually looking for. What I'm going to do is just show you the monstrosity that is the parameter sniffing that goes on here. So for these queries, all of these vote sniffings, vote types 1, 2, 3, 5, and 10, I'm not going to run these in front of you because they run for a pretty long time. If we go look at the saved query plans I have for them, vote type 1 runs for around 15.5 seconds. Right? Vote type 2 runs for around 35 seconds. Vote type 3, another 15 seconds, 12, 15, 14, so like 13.5. So these are all fairly long-running queries, and these are all ones that I've run with recompile. So there's no sniffing here. These are just plain slow. These just don't do so hot when SQL Server comes up with an execution plan for them. And that's sad, because a lot of the times when I talk to people about parameter sniffing issues, a lot of them think that recompile is just a straight up, golden ticket to solve the problem. Sometimes it is. Sometimes you can go pretty far with a recompile hint placed in the right spot, and you can avoid dealing with parameter sniffing, because SQL Server is just going to come up with a good plan each time. But you can also run into just weird stuff where SQL Server goes and just picks a bad plan. Even with recompile, SQL Server is capable of picking a bad plan. Even if you compile a query specifically for a parameter, you can have a bad plan for that. For all these vote types, so 4, 6, 7, 8, 9, 11, 12, we have fairly good and fast plans. These ones I do feel pretty safe running in front of you. Right, so all of those finish in just about 2 seconds. Right, we are on, oops, didn't go over quite far enough. There we are, about 2 seconds. So we're in good shape there, right? And if we look at the execution plans, these are going to get much different query plans from the ones that we saw over here, right? These are going to get slightly different plans than we saw from like the plans that recompile, right? There's a lot of like hashing and craziness going on over here, and like big parallelism and scans and all that. And over here we have something a little bit different. TZH said SQL Server picks a bad plan. Certainly not. Yes, I know, it's insane. But that's the thing about working with databases, is that you're not special. Your query isn't special. Your indexes aren't special. Your schema is not special. I mean, maybe it is special, but here's the thing: is the optimizer is a Swiss Army knife. It is a general purpose utility, and it needs to be good across a wide variety of hardware and indexes and schemas and selectivities and target. Like it has to be good across all these different things, and that's tremendously hard. And most of the time, it does pretty okay. But there's all sorts of stuff that like you and I can do to mess with the optimizer to make it pick something bad. But then there's just blind spots. There's things that the optimizer isn't strong at, and there's just sort of weird edge cases where it makes some funny inference where like something is just costed all wrong. So, there's that to consider. It's not like the optimizer is designed to come up with a perfect execution plan for every possible query. It's sort of a general purpose thing to find a good enough, cheap enough plan pretty quickly. And I'm cool with that. I'm cool with that because people still have to call me to tune queries. So what we're going to do is focus in on a couple vote types. We're going to look at vote types 4 and 1. We're going to look at 4 and 1 because these two queries have fairly different runtimes, but also they have very, very different distributions. I don't want to sit around waiting for vote type ID 2 because vote type ID 2 runs for about 40 seconds, and I don't want to I don't have enough to say to kill 40 seconds every time I need to run this. This one runs for about 15 seconds. I feel very comfortable filling 15 seconds with either badums, whatevers, humming, asking how you're doing, telling you what I ate for breakfast, complaining about not being able to go to the gym, and just various other things. There's like fun stuff that I think I like talking about. Weather is a big one. Weather is a huge one. So what I'm going to do is, even though that we ran this with recompile and there's nothing really sitting around in the plan cache to make this thing useful, or to make to be useful to us running this, what I'm going to run is the store procedure for vote type ID 4 just alone by itself. And this is going to finish really quickly, and we'll get this nice kind of like this is like a wonderfully OLTP-ish execution plan. We have nested loops joins, and we have a little tops and little seeks, and just all sorts of nice little things going on. I also want to point out something very, very annoying about execution plan warnings. If you notice, this nested loops join right here has this red X over it, right? This sassy red X. And if we look at this operator, if we look at the tooltip for it, it's going to tell us that we don't have a join predicate. And this is so absolutely wrong because we have a seek here, and this seek predicate is seeking to a very specific owner user ID in the posts table, and this is searching for a very specific user ID over here. So any rows that come out of this seek, because the seek is going to be coming from user ID values over here, so we're going to pass out one user ID at a time to the nested loops join. That nested loops join is going to go down here, and because this is an apply nested loops, right, we have this outer references marker in the tooltip, which means it is apply nested loops, not a regular old nested loops join, what some might call a naive nested loops join. Because we have this outer references thing here, we know that we are doing what's called apply nested loops, which means we're taking basically one user ID at a time. We're putting that through the nested loops. We're going to seek here and seek here for that same user ID, and then we will, whatever we join together here in this nested loops join, is going to be a match because we are searching for one at a time from these two things. So this happens very, very quickly for us, right? And that's pretty good. And now we'll actually see for vote type ID 1, things be a little bit better than 15 seconds, even though we're using an execution plan that SQL Server did not optimize specifically for vote type ID 1. Amazing, right? When we use a plan that was created for a different parameter, this actually finishes a little bit faster than it does when we come up with an execution plan for it, specifically for that vote type ID. Now, the operator times here are probably going to look a little confusing. Lee says, sorry, but why does it say no join predicate then? Because the warning is very naive. The warning is not aware of the fact that we are doing apply nested loops, and it's just kind of dumb. Sorry, that's all it is. It's just not smart. I wish there was a better reason, but it's just stupidity. Probably something it got implemented by a summer intern, and the summer intern did not think about all the marvels and miraculousness that can occur within an execution plan. It's just not terribly well thought out. Most of the time, you can ignore it. There is when it first got added, people used to freak out about it. I think like a lot of why it got added at first was back when people used to write old style joins, where they'd write like from table, comma table, comma table, and put the join conditions in a where clause, where like, you know, it was fairly easy to forget a join condition and sort of end up with like a crazy Cartesian product from things. But, you know, and I don't know, maybe apply nested loops wasn't around when this thing got added as a warning. I just don't know. But it's pretty poorly done. But, you know, we have the no join predicate warning, even though anything that we seek to here and seek to here is going to be a match because it's the same user ID that gets brought out here. It's just not very smart. So looking at this execution plan, it's a little confusing how things go. So if we look at the properties of the plan, we look at the query time stats, we'll see that let's see. Question, what compat level do you run that DB on? This is 150. 150. We're on SQL Server 2019. Don't mind going to look over here. Oh, that's SQL Server 2017. I'm in there. I did not get rid of that database, or I did not get rid of that server connection. Now SSMS is going to make me wait. Stupid SSMS. If only Azure Data Studio was any good at anything other than developer eye candy, I would like to use something other than SSMS someday. I've tried other IDEs for SQL Server, like what's that, JetBrains one, or like Beaver DB or whatever it is, and just none of them had the same flavor. So let's see. There we go. There's 2019. So let's go look at Stack Overflow, properties, options. This is going to be compat level 150. There we go. There we go. Oh, don't worry. It was my own stupid fault for not disconnecting that server when I switched over to use 2019. Yay! All right. So looking at this execution plan, we can see that, so like when SQL Server runs queries in batch mode, right? We can see a lot of these operators are going to be run in batch mode, even though this is all row store. This isn't column store stuff. This is a new SQL Server 2019 engine feature. It's only for Enterprise Edition, but me using Developer Edition means I get all the wonders of Enterprise Edition for free. Ha ha ha. Go take it live to prod. But because we have so much batch mode stuff going on in this plan, a lot of these operators are just going to be tallying up individual times. That's a big difference between row mode plans and batch mode plans. Now, this query plan is going to have a mix of row and batch mode in it. We can see that this nested loops join is in row mode. So what we'll see is, you know, like pretty much all of like the accumulated stuff from here, this subtree kind of rolled up to this nested loops join. But this hash match aggregate, which is in batch mode, does have sort of the majority of the 8-ish seconds that this thing ran for in it. Now I know it's spilled, and that's not nice, but we can see that in total this thing ran for about 8.5 seconds. And if you want to see another cool engine feature with SQL Server 2019, batch mode. Oh, did we still spilled? Let's give this another run. Wow. Oh, but it's a batch mode spill. Maybe it's just never going to get better. Are you ever going to figure it out? No, you're never going to figure it out. So much for that. So like what I was going to show you is under memory grants, what we should get is this thing adjusting memory grants and saying, I didn't give you enough. Let me give you more. So I think just not moving up fast enough. I wonder how many runs. I wonder if I can do this like a few different times and actually get the memory grant. Yay! It only took 4 executions to get the memory grant right. But now this finishes much faster, doesn't it? Now this finishes in a reasonable amount of time. But I want to show you a downside of that. If we go back and we use vote type ID 4, now we're going to have a different warning over here that says, we have an excessive grant. No. And now if we run this again, that'll probably go away, and we'll ask for far less memory. And if we go back to this one, we'll go back to spilling. So nice try, I guess. but this is going to go back to being slow. Is there a way to tell dev edition to act like? No, there isn't. If I wish there was, people have been asking for it for as long as there has been standard and enterprise edition, but Microsoft has not budged. Don't know why. Don't understand why. So I think the most compelling theory that I have for why there is no button to make developer edition act like standard edition is because they want developers to go out and get all these secret performance features and be able to use fully all of the programmability features. And they want, yeah, exactly. They want you to taste the good stuff. They want to get you hooked on enterprise edition. And then if you try to go live on standard and everything falls apart, then, well, all of a sudden your CPU cores are worth $5,000 more a piece. But anyway, so we just saw one of SQL Server 2019's fancy features. So actually this is a 2017 feature. Batch mode memory grant feedback was a 2017 feature, but with batch mode being available on row store in 2019, it is sort of new to row store. You could do all sorts of things to fake SQL Server out to make it think that queries were going to get fully batchy modey on 2017, even if they weren't, with empty temp tables with column store indexes on them. But not here. Not here. We just get it for free. By for free, I mean with Enterprise Edition. So not really for free at all, right? But so that kind of stinks. Let's see. The cost jump isn't a small one. Can't think of many people do that and just think, okay, I'll spend. Yeah, I mean, it all depends on the organization, right? Some people might find that out and just switch to Postgres immediately. I wouldn't blame them. So we recompiled vote sniffing, right? So we looked at what happened here. When vote type ID 4 runs first, and then we run vote type ID 1 next, right? What happens? Vote type ID 1 uses the plan for vote type ID 4. And what do we get? A plan that runs for about 7-8 seconds. And then now let's turn the tables. Let's run this query for vote type ID 1. And we get this plan, which is a pretty decent plan on 2019. The plans that I showed you over here were actually for 2017. I need to re-screen cap those because things are a little bit different. Lee says we've had issues of late with new performance improvements for 2019 on our managed instance. I would love to hear more about those. Please tell me more. And now when vote type ID 4 reuses, so this actually is a 2019 improvement. So one thing that's actually very cool with SQL Server 2019 is we get these handy dandy adaptive joins. Right? I love it. So let's look at what happens when we post this when we run this for a truly villainous vote type ID. See, vote type ID 5 is going to get a very, very similar plan to what happened for vote type ID 1. We're going to have the same sort of adaptive join thing going on, except this one just doesn't go as well. So that when we ran it for vote type ID 1, what happened? Fast. Right? When vote type ID 1 got its very own Jim Jam plan, everything was great. Now, we'll see what happened. Microsoft support turned off TempDB recompilations, which stopped our instances falling over. That is a very bold statement. I would like to hear more about how they turned off TempDB recompilations. Do you mean recompilations from temp tables or from table variables? Or because table variable deferred compilation is a new thing in SQL Server 2019. I would love to hear more about this one. That is a big sentence, Lee. Some advancements, huh? Okay. Around table variable deferred compilation or something else. Inquiring minds. Still trying to get you. If you're still trying, Lee, you may never. Your efforts may be in vain. I don't know. I don't know. It's all craziness. Ooh. We have we have a blog post. Let's actually bring this up in the browser so everyone can see it. Let's be nice. Let's be nice people. Ooh, Joe Sack! Handsome Joe! Oh, don't you just love when Joe Sack blogs? I love when Joe Sack blogs. I get so excited when Joe Sack blogs. He's like one of my favorite bloggers. So let's see. Reduce recompilations for workloads using temporary tables across multiple scopes. Woo! That is a mouthful. Let's see here. Create or alter outer proc that creates a table and then executes an inner proc. No. This is fine. This is the kind of railroading that I live for. And then inner proc will insert into outer proc and select ID. Okay. And let's see. We create a temporary table. Ooh. Huh. CU5 included a fix for that feature. Yes, it sure did. Lucky CU5. Thanks for that CU5. The CU5 stuff for the scalar UDF inlining was especially troublesome. Temporary tables across multiple scopes. Who would do that? If you have to ask that question, you have not lived the nightmare life of a consultant who has seen what many independent software vendors do to SQL Server. Where you're like, have you used a database? Do you know what to do with a database? So let's see here. The end result is a reduction in unwarranted recompilations and associated CPU overhead. The number of occurrences, with the blue line representing batch requests a second and the green line representing SQL recompilations a second. So that is quite a bit of recompilations up here, and quite a low number of batch requests a second here. It's funny because they share very similar spikes and peaks and valleys in those. And this one over here, wow, you push that way up. The feature was enabled after we saw improved throughput. Wow, thanks, Joe Sack. Everyone say thank you to Joe Sack. Everyone go on Twitter and say thank you to Joe Sack. Let's see. There we go. Let's thank you, Joe Sack. I love Joe Sack. But yeah, they turned that off. And suddenly our post-deployment scripts would work and the instance would stop falling over to the other node. Well, that sounds like a win to me. Sounds like a big win to me. I would like it if that stopped happening. But now I have to ask Lee, what are you doing with temp tables that made your managed instance fall over during deployments? Now I'm fascinated. Now I need to know what's going on with these deployments. All right. So when we run this stored procedure now, so we saw vote type ID 1 get a fast plan. We saw vote type ID 4 get a fast plan. We even saw vote type ID 1 use vote type ID 4's plan and be okay. But what struck me, what caught me out, is just so crazy and odd, just so bananas, is when I run this query with vote type ID 5, this thing takes 2 minutes and 17 seconds. Now, the blog post that I wrote about this, I was using a full-size version of the Stack Overflow database where this thing would run for like 15 minutes. I'm using the 2013 version for this because, I just don't want to make you wait 15 minutes. All right, that's bad news. Lee says, nothing special. I checked this section of the script. It's the Wild West with those managed instances. Okay, all right. I mean, I'll believe you on this one, Lee. I'll believe you on this one. If we look at where a lot of the time is spent in this query plan, this index seek is not slow. This compute scalar is not slow. This index scan is not slow. I know everyone freaks out when they see index scans, but this index scan is 129 milliseconds. I'm pretty hip to the speed on that, and I'm pretty cool with this one taking 167 milliseconds. Now, since this join is adaptive, we're going to see a second potential join down here, but you can kind of tell by the width of this line that it didn't do any work. a lot of the time in this query is going to get spent here and here. Right? We can see that pretty well, right? If we go look at the total execution time on this, we will get a long time. Why are you linking to other people's Twitch streams in here? I'm gonna ban you for spamming, Coyote McD. I'm gonna kick you from the chat forever. Dead to me. You're dead to me. So what happens up here? Something kind of interesting happens, where this hash join is running in, let me just bring up the properties of it, because the properties of it is where we get all of the information kind of happening at once. So the execution mode over here is batch, and if we look at what it's up to, we can see that it is a bitmap creator. And it is true that it has created bitmaps. Right? So we created a bitmap, and we use that bitmap down over here in this part of the plan. This index scan and this index scan. Now, you can see that there's a fairly bad estimate from one of these, right? One of them is pretty good. The other one is pretty bad. But if we look a little bit closer, oops, there we go. Look a little bit closer. We have a predicate that wants to probe with this optimized bitmap filter. What are we even doing here? What are we doing here? We are trying to apply a bitmap filter to this index scan. It is not going well. Actually, you know what? I take that back. It might go spectacularly well. The problem is that we get a very, very bad estimate because of that. Now, I'm going to stick a link into chat for a very, very smart post. If I can learn how to type. By the patron saint of SQL Server performance, Paul White. It's about batch mode bitmaps. And you can kind of get a feel for just how naive a lot of the cardinality estimates for batch mode bitmap filters are. And since this hash mode semi-join over here is a bitmap creator, and we use a bitmap, we get a pretty bad bitmap estimate. Lee says, I still don't fully understand bitmap's role. Yes. They can be rather difficult to grasp. If you might help you understand a little bit, let me grab another link for you. Where are you? There you are. Ha 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 ha. Where is? Yes. I just need to make sure to mute myself from there. So I have a video, an old style video over on YouTube about useful versus useless bitmaps that might help you get some understanding on that. Don't watch it now though, because it'll just be distracting. And if you hear me talking from two different videos at once, your head might explode. It might not be the most fun time in the world for you. So this is not a particularly good plan for vote type ID 5, and it's not a particularly good plan because of the bad estimate that we get from that bitmap over here, where way more rows come out of this operation than expected, right? We expect 6,000 and we get, let's see, 3049341, so we get back 3 million. And worse, when we join the 3 million rows from posts to the 8 million rows from badges, we get just about everything, right? So we have another bad estimate. What's the CPU time on what? Coyote McD. Be specific about on that, and I will happily answer you. So we get this adaptive join, and this adaptive join is a join just like any other. You want to know what the CPU time on this is? Let's look. Why am I not seeing where you go? There we go. Yeesh. I don't know why that took me so long. There you go. So 11,000 seconds. or 11,000 milliseconds rather. So that's fun. But the elapsed time on that's a stinker, right? What happened there? What happened to you? Let's look at... Oh, that's not too bad. It's not so bad at all. You could do far worse than that. So we've got this adaptive join, and this adaptive join spills because we have just some bad guesses going on over here. How much it spills? Not terribly bad. Right? They're hash spills though, so hash spills can get kind of weird. But really, and what struck me, I think, most while I was trying to figure out what was going on here is that if we had a better guess, SQL Server might do things differently. If SQL Server had made a good guess about how many rows might come out of like one of these, we might see an aggregate over here somewhere. So we see an aggregate over here. SQL Server decides to smush a whole bunch of rows down to one row here. But I think if SQL Server understood that we were going to end up with, let's see, 217292920 with a 9-digit number of rows here. Because remember that we have to take all the rows that come out of this index seek. We build a hash table here, and then we have to probe the result of this join, which when you have a guess that's off by 605,000%, becomes quite a chore. So all the results of the index seek on the votes table, right, which is correct, right? That's an accurate guess, right? That's 100% there. SQL Server was spot on with this one. SQL Server was spot on with this one. But when we get here, and we have to all of a sudden take the rows from the votes table, and we have to probe into the results of this adaptive join, probing into the 217 million rows. Yeah, the 217 million row result of that adaptive join is unpleasant. Now it's unpleasant because that's just a ton of rows. Like all of a sudden, like this thing running for 2 minutes and 20 seconds makes a lot of sense, because that's just a lot of work to do. It's a lot of probing to do, right? That's an unhappy amount of probing to do. What I thought was very, very funny, kind of about these circumstances here, though, was if we take the recompile out of the equation, right? Let's just take recompile out. Let's leave recompile out of it for now. Let's run for vote type ID 4, and let's get this wait, no, we do have to recompile the proc because I used it for something else. There we go. Let's get vote type ID 4 and let's run that. So now we have the vote type ID 4 plan, and let's get the vote type ID 5 plan. So let's parameter sniff on purpose. Let's have a parameter sniffing party, you and me. Let's all get together and do that. When we reuse the plan for vote type ID 2, what happens? It finishes almost immediately, right? That runs in about 2 seconds. If we look at the query time stats on that, 2 seconds. So let me ask you a funny question. If you had a query that started showing up on monitoring as running for 5 minutes or 2 minutes and something seconds, and you saw that maybe the compile time parameter and the runtime parameter were different, you were like, oh, we got a parameter sniffing problem. But it's not quite that, is it? Because if we run this store procedure for any of these queries except vote type ID 5, we get the exact same execution plan that we get when vote type ID 5 runs. There's no real difference between them, and these all finish relatively quickly. It's the same execution plan over and over and over again, right? And we're recompiling all of these, so we're coming up with an execution plan specific for 1, 2, 3, and 10. But when 5 runs, whoo! When 5 runs, even for itself, the execution plan for 5 sucks. When 5 uses another, even any one of the other like tiny little plans, 5 does fine. We almost have reverse parameter sniffing because the plan that we get for vote type ID 5 sucks for vote type ID 5 very specifically. If any other query uses the plan specific to vote type ID 5, it'll do just fine. If we recompile this, right, and we run for 5 first, oops, you know what? We're not going to run for 5 first. We're going to run for 1 first because 1 gets the same plan as 5, right? It gets the same adaptive join plan. We get all that stuff. And we rerun this for 4. 4 does just fine with this plan. 4 just shrugs it off. 4 is like, you know what? I got this. It's when vote type ID 5 gets that really, really bad guess, everything just goes to crap. So how can we fix vote type ID 5? How can we remedy vote type ID 5? How can we get in there and start messing with things? Well, one way might be a temp table, right? So if we create a temp table called votes and we put that initial part of the join, or the initial part of the query that filters down to the vote type ID, right? So because remember, Lee says a query hint. Sure, what query hint? Tell me which query hint to use. So if we filter down to just the vote type ID we want first, what we can do is take the results of just vote type ID 5, isolate that, isolate the cardinality involved there, and then maybe we can do a better job with this query, right? With this execution plan. Maybe stabilizing that will be a good idea. Let's sacrifice one of these things to be vote type ID 5, and let's see what happens. Now my computer over there is humming, so I know we did some work. I know we did some work, and what happens here? Well, that's pretty all right. Oops. That's pretty all right. Do an index seek over here. Do a couple of stream aggregates over here. We insert the results into our temp table over here. Whole thing takes about 1.5 seconds. And now then we have a pretty quick query over here too. Now, notice something. We still end up with the exact same execution plan that we had before the temp table, right? So what happens in here is nearly identical. We start off with the votes table up here. We compute a scalar. We have a hash join. We have an adaptive join, and then we have posts and badges over here. So we make like just about all the same mistakes, but we just don't have that same terrible performance. Pretty crazy, right? So this is another place where paying attention or paying too much attention to costs and estimates and all sorts of other things like that can sort of be detrimental to query tuning. The estimate isn't as wrong. No, it is just as wrong. That is off. But well, I mean, okay. So yeah, that is slightly less wrong, but it is still wrong. It's not as wrong, but it is still pretty wrong. So it went from 6,000 to, so it went down by, I don't know. I'm not exactly sure what an order of magnitude is. I hear it's a big number, but yeah, this went from 605,000 to 6,000. So it's still wrong by a big chunk. But I don't know, what would I fix in here? Taking 1.9 seconds? I just don't know what I would do in here. And if we go look at the query time stats over here, what would I fix? I don't know. I don't know what I could fix in here to do better. This thing up here is still up to the same nonsense with the optimized bitmap. The optimized bitmap is still the reason why we get this not good situation here, right? I don't think it occurs down here though. Oh, it does. Interesting. So I didn't notice that before, but the optimized bitmap actually gets applied to the badges table this time too. In the previous plan, we didn't get that. We didn't have that extra bitmappy goodness. So that's actually a fun new thing that I just noticed in here. Is the bitmap gets double applied. I wonder do we have a bad estimate here? Yes, we do. Now we have a bad estimate here. Now we have an estimate of 490%. On the old plan, this was spot on. So we actually we got 2 bad estimates from the same bitmap. Isn't that sweet? It's so nice when bitmaps just work out like that. It's so nice. It's so nice. So let's look at something a little bit different. So we looked at a couple of possible different ways, or we looked at the like one way to rewrite this using a temp table up here. I think my main beef with this though is like if we had to do that for vote type ID 2, right? If I run the same proc for vote type ID 2, we have to put kind of a lot of rows into a temp table. Probably more like if this was a highly concurrent store procedure, if this was something that was running a lot, it was like really just like, you know, like a critical part of the application, we could end up you know, like kind of having to do a lot of work, right? Like in some cases, like we might end up having to put a lot of rows into a temp table. This also takes about 10 seconds total, which I'm like not thrilled with either. No, and it's just it's all spent up here, right? It's all up in this top part. So like, I don't know that I'm thrilled with this. Right? I don't know that this is like I don't know that I'm really psyched on the like that for the temp table. Right? I don't know that I just want this thing like pounding around on TempDB. So let's look at a couple different ways that we might be able to rewrite this. Now, this first one was all my idea. This one was mine, I think, at least as far as I know. I'm going to show you another one from a smart friend. But this one here, what we're gonna do is rather than you know, use the votes table to drive the temp table, we're gonna use the post table instead. So we're gonna use that first join between posts and badges, and we're going to have an exists back to the votes table to make sure that we really narrow down the number of rows that we care about, right? So let's, oops, that's F4, not F5. And that ends up pretty quick. Oops, I didn't turn on execution plans there. Let's try that again. I'm gonna have to drop this P table, right? Can I get an expert witness on dropping a temp table? We'll just say drop table P. You know why? Because we can do that. We are live. We are live in dev. We can do whatever we want. We can do what we please. All right. So that takes about 2.7 seconds, and that's a pretty reasonably small number of rows, right? Like I'm not going to cry over a 200,000 row temp table. And then if we run this query, just looking for what's in that temp table instead, and I'm going to actually, you know what, I have to redrop P, don't I? So I'm going to run that all at once now. I wanted to make sure that we had the temp table insert isolated just to see what that looked like. So now when we run this, that's about, boy, that varied a little bit, didn't it? Yes, select 1, 0. And then this part runs relatively quickly. All right, so we simplified this part. I don't know that I'm thrilled with like this part, this temp table insert. I don't know. Maybe I'd stick with the votes one. So like I don't know. Like so thinking about yes, select 1, 0. It doesn't do anything. It's in it exists. So thinking about like what I would do with a situation like this, where if I knew that if like at some point like I could have a query that runs about a second faster and uses potentially more TempDB, or have a query that takes an extra second but uses a reliably small amount of TempDB, I might just opt for losing a second, depending on my system, depending on like sort of depending on like, you know, the like what I care the most about. If we're just going purely for time, I don't know. Maybe I would pick the slightly more abusive to TempDB query. But since we have a choice, we can figure maybe we don't need to do that at all. So this was user submitted by my dear friend Paul. My dear friend Paul from New Zealand. And he came up with this query, which is insane and typical of Paul, outdoing me in every possible way. And this doesn't need a temp table at all. Right? So we're going to create this, we have to create a slightly different index in order for this to really shine, but it runs pretty well. Lee says, I realized I'm guilty of getting it fast rather than thinking about cost. Well, you know, don't think about query cost. Query cost is a not even like query cost is a not good metric to think about. You know, the cost that I was thinking of was more related to you know, resource usage with TempDB, which, you know, TempDB is kind of made for that. TempDB is like kind of made to take a beating, but, you know, you can certainly run into strange contention up in TempDB. You know, if I really wanted to spend a long time on this, I might try to use like ostress or something to run a whole bunch of copies of this all at once, and then, you know, kind of like, you know, see if like I could hit some like what kind of TempDB contention I could hit, sort of like, you know, just like running like 20-30 copies of this. Option max stop 80. Coyote McD, here's the thing, man. You have servers where you could use, well, you can't use max stop 80, can't you? You can use max stop 64. You could use max stop 64. TCH says, are the differences between temp tables and table variables any different in newer versions? They are only slightly different in SQL Server 2019. If you tune in tomorrow, I'll talk about that. I think that's a good topic for tomorrow. So tune in tomorrow and we'll talk about the difference between temp tables and table variables in SQL Server 2000. That seems like a good, you know what, that sounds like a winner. Now I'm mad I didn't think to do that one today. It's talking about this stupid blog post query. All right, so with this, let's see how this goes. Let's turn on execution plans. Let's make sure that we get that. And once again, Paul has absolutely wrecked every single thing. He's a madman. So this finishes in 700 milliseconds and doesn't require a temp table at all. It is kind of strangely written, right? It is kind of strangely written, and we do have to force the index here. I forget exactly what happens if we don't. Yeah, it goes back to using the other index. So you know what? Let's get rid of that one. Come on, Pally. Index on votes. There we go. Now let's see what you do. There we go. So even without the index, and with just that index in there, we do pretty well. And this is without a temp table at all. We do still have this annoying warning on the nested loops join, which is completely wrong, but that's okay. What we don't have though, or more importantly, what we do have that's very, very important, and this is I think what makes the biggest difference in here. Right? If we think logically about all the things that we've looked at with this query and not liked, the biggest one is that SQL Server was not choosing to aggregate any of the join stuff prior to a join, right? Like none of the join columns are getting aggregated before we went into the join. If like logically, like you and me thinking about it out loud, like there's like if we know that a column is not reasonably selective, a column is not reasonably unique, if a column is going to have a fair amount of duplicate values in it, we would probably want to aggregate that down to as few values as possible to going into the join. And that's what happens here. We seek into the votes table, but then we also pre-aggregate our join column a little bit. If we hover over this, you will see that we aggregated the user ID column from the votes table down to however few rows we could reasonably aggregate it down to. So let's see here. We started with, let's see, 3511733. So we started with 3.5 million rows, and we were able to aggregate that down to 267,000 rows, which is a substantial reduction in the amount of work we would have to do at join time. And then this has to do a lot of work. Let's see, Coyote McD says that's a lot of seeking. Does RCSI make a big difference in lock overhead on this one too. Yes, but let's see. What would be a good way to show that? You know what? We can just come back over here to this one. We need 4 and 1 and 1 and 4. So what Mr. Coyote McD is asking about is sort of a follow-up blog post to this, where if we run this, what we'll get is, so this is one that I think went out yesterday. It was about how read queries need to take locks too, right? Read queries take locks unless there's a lookup in the query. They don't accumulate locks the way modification queries do, though. They don't like build up over time. They just kind of get taken and released, again, unless there's a lookup in there. If there's lookups in there, you're screwed. Locks can hold on for a while. But if we run this query between 4 and 1, the vote type ID 1, actually, I'm not sure which, did we? Yeah, so we're going to do the same thing. So looking at this now, this ends up taking a whole lot longer to get those rows in there, even though it takes 7.5 seconds to put one row into this temp table versus, it taking like nothing for this one. Right, and now we could play with it a little bit. I don't think we have any batch mode operators in here. I want to double check though, because we might get enough of a memory grant connection to help with that, but I don't think so. No. So this 2 stream aggregates aren't going to be valid for batch mode, right? They're not going to be batch mode eligible. The compute scalar is in row mode. This compute scalar is in row mode. This index seek is in row mode. And this sort is also, so this is all row mode stuff. So we're not going to get batch mode memory grant feedback on this. We would just get the same crappy 7.5 second plan over and over again. At least I think we would. Pretty sure we need that batch mode stuff. Oh, it was a little faster, did we? Oh, no, I guess it did. Let's go look. Oh yeah, yes, adjusting. Good. Oh, that's nice. Wonder what we're getting that from. What a nice touch. Thanks, Joe Sack. Thanks again, Joe Sack. I'll draw another heart on your head later. But what's interesting, though, is if we run this for vote type ID 1 first, well, this is faster. We go parallel there. But vote type ID 1 and 4 run much more quickly. And so, but what Coyote McD is getting at was sometimes you do have to, there can be overhead. So let me grab the blog post that he's referencing so that everyone has it. You don't have to go searching for it. The last thing I want anyone have to do is go searching for things. Is that under some circumstances, the locking overhead of reading data from a table can be particularly loathsome. So one way to test that is to, let's say, add a page lock hint here. And we will get, so long as the demo gods are smiling upon me. Oh, that could have gone better. Highlighting was never my specialty, folks. I apologize. I apologize. Demo gods are not smiling upon me. This is what happens when you go off script. Thanks, Coyote. But at least this part here, at least for this one, the index seek was alive. It was 1.5 seconds before. It was only half a second this time. So thank God for that. Thank God for the little things. So yeah, that's fun. Triple click for a single line highlights. Yes, I know, but I don't. I'm an old-fashioned guy, and I just highlight things. I would have messed up the triple click and done something silly there too. Anyway, it's been like an hour, and I need to go hang out with my kids apparently. So I'm going to get going and do that. If we have any final questions, anything you want to ask about, know about, SQL Server stuff, now is an okay time to do that. Let me go back over to this one here, and let's go look at this. All right. I'll hang out here for a minute, see if anything comes into chat. Let's see. Thanks to one of your videos, I found a deadlock in a database, which I solved with an index. Nice. All right. Mr. P, you're welcome. Mr. P. Shaw, you are absolutely welcome. Lee says, thanks for the stream. No, Lee, you can always ask more questions. That's what I'm here for. If you don't ask questions, I don't have answers. Isn't that sad? Just all these things locked away in my head that I don't have answers for. That I have answers for, that I just can't use. All right. So since we're just getting some thank yous and we're not getting any questions, I'm going to bow out here. You're welcome. I will see you tomorrow. And tomorrow we will talk about the differences between temporary objects in SQL Server 2019. We are not going to go back through the sands of time to other versions. We're going to go right to SQL Server 2019, and we're going to look at all that fun old stuff. So I will see you tomorrow. I will try to get on a little bit earlier tomorrow, so you fine folks in Europe don't have to stay up past drinking time to hang out with me. But I'll announce it on the old Twitter and whatnot when I'm about to go live. So I'll see y'all tomorrow. Thanks for joining me. Take care, and you know, be excellent to each other, as a wise man once said. All right, adios.